In this video, we are looking at linear functions. And in the course, we actually look at lots of different functions, but we'll start with linear functions. But all of the similar things that we do with linear functions, we do with all the other functions. I hope you like my picture there. There's me in the foreground with my Lost Soul Ultra hat. That's a great race. If you've never done a long ultra race, something to try. So we're going to look in this video at determining the slope and y-intercept of a line, and we'll also look at graphing some. Just as we get into looking at functions, this is something the textbook looks at, and it's a common thing that we do when we're looking at numbers. Often we get, in math, we get messed up, not messed up, confused, I guess, or uh, submerged in x's and y's and moving these things around and factoring these things. But keep in mind that all the stuff that we're doing in math, what we're doing is really modeling things. So a linear function, it's a function that is a straight line. And when we look at anything in the world, any kind of pattern, we look for stuff like that. So we identify an issue, some kind of thing that we want to look at. We collect data, we graph the data, and then based on that graph, we try and match some kind of an established model. We'll see some of those on the next page. And then the power of being able to pick a model is that then we can explain and predict something that's going to happen in the future. For example, we're currently in this pandemic with the COVID-19 virus, and governments all over the world are looking to try and find a pattern and some kind of an established model. It seems to me, initially anyway, right in this phase here, that what we had was an exponential model. But since then, it looks like it's changed into a linear model. And I haven't looked at all of them. But based on these kind of patterns, we can predict where this number is going in the future. And maybe we can predict when it might start leveling off. Okay, so here's a bunch of the functions we're going to be looking at in this course. This first section, we're looking at linear ones, but then we're going to look at all of these other types of models or established models. One of the tools that you'll find very useful in the course is a graphing calculator. And the one that you can use for free is, and you can get it on your phone or computer, wherever, is DESMOS. And so you want to be familiar with DESMOS and how to use it. I was just going to graph a quick function here and just show you a few things. So you tap in this location up there. Whoops, see where it's flashing top left. And then you type in your function. So say I wanted to do this y equals 2 to the x. So I hit a y and then an equal sign and then 2. And then you look for the exponent button. It's like AB. And then up top there, I'm going to put an X. And there it graphs me what that function looks like. Now, the interesting thing with the function is you can tap on things that might be of importance. And you might see that little dot right there. And that tells you what, in this case, what the y-intercept of that function is. Let's just quickly do this fraction one, the bottom one, the linear function. So y equals 5 over 4, so 5 divide 4, and then I have to move over because I don't want my x on the bottom. See, if I hit an x now, it goes on the bottom. I don't want an inverse function. Let me hit backspace. So I have to go over a bit, and then I hit my x, take away 3. There. And so there is my function graph. And I can tap on specific spots of it to find out what what that particular property is. Now, when you're looking at linear functions, there's a couple of properties that you want to look at. And why we're looking at properties is we can take those properties and put them into a function, and then that function can describe our graph or our data. So all linear functions, what the important things that we look at is where it crosses the y-axis. Okay, there's a y-axis, so where it crosses the y-axis. Now, we could find where it crosses the x-axis, But it turns out that in the equation, typically we don't do that. We don't use that. So the other thing that will describe a linear function is what the slope of the line is. So this one is rising to the right. It has a positive slope, but we can put a number to it. So how much does it rise, say, from there to get to there, and then over to there? Well, I aren't that straight. But this would be my rise, and this would be my run. Okay, so a combination of where it crosses the y-axis and what its slope is, that'll tell me what the function, the linear function is. And when I write that as a function, I write it like this, where y equals mx plus b, where m stands for the slope of the line and b stands for the y-intercept. Okay, so here's a couple of questions where they say, what is the slope and y-intercept of the line? When you look at this equation here, it's written in a perfect form because m is the slope. It comes in front of the x. That's this thing right there. Notice that when I say what the slope is, I don't say it's negative 2.3x, it's just negative 2.3. And the y-intercept, of course, is 4.2. In this one below, the slope is 5 over 4, and the y-intercept, or b, I don't know why they use the letter b, but whatever. The y-intercept is negative 3. Now, one thing I should note with the y-intercepts is that, yes, you can say b is 4.2, but really the y-intercept is a point, so it has an x and a y value. The 4.2 would be the y value, and the x value would be 0. So this y-intercept would be 0, negative 3. Now those are fairly straightforward to do, but there are some questions where you have to do a little bit of work before you get them to, before you can determine what the y-intercept and the slope is. I need to get to this equation or this form of the equation, and this equation doesn't look like it. So I'm going to subtract 3x on both sides, leaving me with minus 2y is equal to, I'm going to write the minus 3x first, and that's a positive 12, just so it's in this form up there. Now I'm almost there. I just have to get rid of that minus 2 in the front there. So I'll divide everything by minus 2. So these all cancel, leaving me with a y on the left side. On the right side, the 2 minus will cancel, so my slope is 3 over 2x. 12 divided by negative 2 is negative 6. So now I know my slope is 3 halves, and my y-intercept is 0 and negative 6. That's the point. Okay, the next one, try that. Press pause and then try it and then see how you do. Okay, I would write it as minus 2y equals minus 4x plus 7. Dividing everything by a minus 2, I'm going to get a 2x minus 7 over 2. So my slope is 2, and my y-intercept is negative 7 halves, where the point is 0, negative 7 halves. Now, we can also, when we look at a linear function, we want to know where the slope and y-intercept is, but we also want to graph that, because a graphical representation, we can compare those, and it's nice to be able to graph them. When you graph any linear function, always start with the y-intercept, and then from the y-intercept, use the slope to get a second point. So my y-intercept is negative 2, that's a point right there. Then they say my slope is 3 over 4. The top number is always the rise, and the bottom number is always the run. So I'm going to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. So there's my other point. Now, these lines that I put in between, I probably don't need those. There. Okay, so there I have 2 points, and now I can draw a line that goes through those points, and that would be the graph of that particular function. You can also do these in DESMOS. Let's try one. Try in DESMOS and see how it works. So y equals 3 over 4. So 3 divide 4. Move over x minus 2. Uh-oh, where's my 2? There. So if you take a look, Ours looks very similar to the one that DESMOS showed up. And again, you can confirm things by tapping on the y-intercept there, and that tells you what your y-intercept is. Again, we don't need the x-intercept, but if you wanted to know it, it was there. Okay, try one. Try doing it on the graph paper first, and then try to do it on DESMOS. Okay, so for this one, I'd say +1 is my y-intercept. Then I go up 2 and over 5. That would be right there. So that line right there is my graph. And again, do it in DESMOS. Okay, so we've seen how we can graph functions, but what if I have a graph and I want to figure out what the function is? So what is the equation? I want this. So you can do that by just looking at the graph, see where it crosses the y-axis. Looks like it's crossing there at 1. So my b value will be 1. And now all I have to do is figure out what the slope is. So I need to find a point that I'm pretty sure is on the graph. When I look at this, it looks like that one is pretty well bang on, or this one down here. The other ones seem to be like apart, so I don't know if I'll use those. You can use any one of them, but I like using the ones that look like they're bang on an intersection. Okay, so to get to this point up here, let's say, I have to rise, so my fraction is like this, so rise 1, 2, 3, 4. So I'm going up 4. And I always like to think if I'm going up, that's positive. If I have to go down, it's negative. If I have to go right, it's positive. If I go left, it's negative. So I've gone up 4, and now I have to go over 1, 2, 3. Oh no, not 3. Sorry, I didn't look at the scale. 6. So I'm going over 1, 2, 3, 4, 5, 6 to the left, so that'd be a -6. Now that's a fraction that I should simplify. So 4 over, not 4, 2. What's happening here? 2 over a -3, x plus 1. Typically the negative sign doesn't go on the bottom, so typically we put it on the top. And on the if you put it on the top, that works too for slope, because if it's -2, you would drop 2. So you drop 2, 1, 2, and then move over 3. So 1, 2, 3. Sure enough, gets you to the same line. Try that one there. See if you can come up with an equation for that line. It's y is equal to something x plus something. Okay, hopefully you've tried it. See if you come up with the right answer. Your y-intercept is -2, so there'll be a -2 here. And now I need a fraction for my slope. So let's find another point that's sort of bang on. Looks like right there. Okay, so how many do I have to go up? I have to look at my scale again. So this is 1, 2, 3, 4. I'm going up 4. And then 1, 2, 3, 4, 5, 6. Oh, it's the same ratio, just positive this time. So 4, 6, if you simplify it, is 2/3 x minus 2. So sometimes you will be given 2 points and asked to find the slope. Rather than giving you an equation, they'll say, here's 2 points, find the slope of the line. And here's 2 formulas that you can use to solve that. So you can use either rise over run and a good graph to help you, or you can use the equation y2 minus y1 over x2 minus x1. I'll show you how to do both of those. So here I'm asked to find the slope of a line with those 2 points that are on the same line. So 3 minus 1, 1, 4. Let me plot those points first. So 3 minus 1 right there, and 1, 4 right up there. So I have a line that goes through those points, and I want to know the slope of that line. It looks fairly steep. It also is going up to the left, so I know it's a negative slope. But let's use both the rise over run and this formula to figure out our answer. So rise over run. So you pick any point and you see how many times you have to go up or down and over, left or right, to get to the other point. I always usually start with the point that's on the bottom for no reason, but that's where I start. Okay, so I'm going up, so it'd be 1, 2, 3, 4, 5. So I have to go up 5. So for my slope, I'd say my rise is 5, and then my run is 2. Is that the right scale? Yeah, 2. But I went to the left, so I would call it a -2. So my slope, you could write it, typically we write it like that, but you could put the negative right in the middle. So either of those three would be correct. Let's try doing the same thing, but with a formula. So when they give you 2 points, either like this, or they might write them like that, they both mean the same thing. You have to figure out what point is your x1, which point is your y1, etc. So you pick one point, say this point, and these are all going to be number ones. So this 3 is a x1, and this is a y1. So this number here will be an x2, and this number here will be a y2. Then you just plug them in. So y2 is a 4 minus y1 is a -1. Ooh, two negatives. Let's write it like that. Over x2, right there, 1, minus x1 is a 3. Okay, 4 take away a -1. These two will cancel to make positive. So 4 plus 1 is 5. And 1 take away 3 is a -2. See how we come up with the same answer. One on your own. Press pause, try it, then press play and see if you get it right. All right, so -3, -2, that's that point right there. 2 and 4 is this point right there. So my line is going like that. And I want to know what the slope is. So it looks like I'm going up 6. And over this way, 1, 2, 3, I'm going over 5. So I'm running 5. So my rise is 6 and my run is 5. And it's a positive slope because it's going up to the right. Let's see if we can get the same answer using our formula. So this is, let's call x1, y1, x2, y2. Okay, y2 is 4 minus y1 is a -2. You see how you're going to have to be careful with those. Over x2 is a 2 minus x1 is a -3. Ooh, a couple of negatives. Okay, so 4 take away negative. These will change to positive. So 4 plus 2 is 6. Good. 2 minus a negative, so these will change to plus. 2 plus 3, 5. Same answer. Last concept I want to show in this video is the equation of horizontal and vertical lines. Horizontal lines, ones like this, are always in the form of y is equal to some number because they're always up above the axis a certain amount. Vertical lines, like this one, is always in the form of x is equal to because they're always so far left or right of the axis. So let's try to do a couple. Let me just get rid of my lines there. Let's try to write the equation of horizontal and vertical lines. They go through that point. So 4, 2, that's that point right there. So let's do horizontal first. So this is my horizontal line, goes through there. And so the equation of my horizontal line is y is equal to, and I'm just looking to see how far y is up all the time. If it's a straight horizontal line, y is always going to be a certain amount. And in this case, it's 2. Vertical line, the vertical line that goes through that same point would be this line right there. And if you notice, it's always a certain amount off of that axis. It's always to the right a certain amount. And it looks like it's to the right 4 units. So x is equal to 4. That would be the equation of this vertical line. Try one on your own. What are the equations for the horizontal vertical line that go through the point? -2 and 5. That point right there. So horizontal line, this one is going to be y is equal to, and it's up 5. So y is equal to 5. And notice it's just that number. and the vertical line that goes through that same point right there is going to be x is equal to, and it's always over -2.
Here's just a quick question that is a worded problem, but it's one where we're looking for slope, basically, or rate of change. It says in 2010, town has population 12,000. In 2020, the population increased to 15,000. What's the average rate of population increase per year? And so to do slope or increase, typically what we're looking at, and we've seen two formulas. We've seen rise over run. We've seen y2 minus y1 over x2 minus x1. And this one here would be probably the change. That's what delta or triangle stands for. They say, what's the average rate of population increase? So that'll be on top. So change in population over the change in time or the change in year. So to figure out the change in population, take the last year, the population in the last year, 15,000 minus what it started at, 12,000. You see how it's very similar to this one? Divide that by the change in years. So I ended in 2020 and I started in 2010. So when you look at this, the top will be 3,000 and the bottom will be 10 years. So if you divide those, you get 300 additional people per year. All right, okay.
Okay, so in this video, we've looked at what linear functions are. We've seen how you can get slope and y-intercepts from an equation or from a graph. And we've also found slope and written the equation of both horizontal and vertical lines. Try the video quiz, the homework quiz, etc.